Have you ever wondered why electric vehicles on the market today must be bundled with a ton of autonomous driving and smart cabin features you don't even need? If we only want a motor, a battery pack, and 4 wheels, and strip away all those LiDARs, high computing chips, and flashy multi-screens, to build a truly pure electric vehicle, slashing the price directly, wouldn't it sell like crazy? It absolutely would sell like crazy. But why are automakers dead set against doing it? Today, we will look at the underlying logic of electrical and automation engineering. To strip away the true cost structure of the EV industry, you'll find that it's not because automakers don't understand you, but rather the ironclad laws of industrial manufacturing and power electronics architecture that dictate a cheap, non-smart pure EV in today's supply chain is fundamentally an extremely difficult business proposition to achieve. Let's not talk about vague technological visions. We'll only talk about hardcore manufacturing data and physical reality. This video will be divided into 4 main sections. First, from the cost structure of power electronic systems, which is the perspective of industrial automation, we'll tell you why removing smart driving barely reduces the overall vehicle cost. Second, we'll dismantle the smart driving system to see its true proportion in the entire vehicle hardware bill of materials, and why automakers insist on pushing this software on you. In the third section, we'll compare the current price gap between EVs and traditional ICE vehicles in Taiwan to see where the problem actually lies. Finally, we'll bring out real combat data from mainland China's auto market, where electricity is cheaper than oil, to prove that as long as the price is right, adoption rate is not an issue at all, and point out the key nodes in the future that can truly bring electric vehicle prices down. Part 1. Why removing smart driving still doesn't make EVs cheap. Many people have a misconception, thinking that EVs are expensive now because they are equipped with too many cameras and radars, and those high-end AI chips with hundreds of TOPS of computing power. If we just dismantle all these things, the car price could be reduced by $200,000 to $300,000 NT. But in the mindset of hardware engineering, this is a huge misunderstanding. In the field of industrial automation, when we are planning the drive architecture for clean rooms or large machinery, the most expensive components are never those responsible for sending signals, like PLCs, programmable logic controllers, or upstream industrial computers, but rather the servo motors doing the actual work below, the inverters, and the power supply systems providing massive energy. Electric vehicles follow exactly the same logic. The cost of a pure EV, with over 60% to 70% of it, is firmly tied to the so-called 3 electric system: battery, motor, and electronic control. Let's start with the battery. It's the biggest cost monster in the entire car. If you want reasonable range, say 400 to 500 kilometers, you must pack in a 60 to 80 kWh battery pack. This pile of batteries is full of lithium, nickel, cobalt, and manganese, major raw materials. Their prices fluctuate with the international futures market. You can't just write a couple lines of code to make the battery material costs vanish out of thin air. It's like going to buy pure copper cables. The price of copper per kilogram is fixed. The physical volume and energy density limits are right there. Next is the motor and electronic control. We've seen countless servo motors in factories. If you want high motor torque and high efficiency, your rotor design and the material of the stator winding silicon steel sheets cannot be sloppy. In order to process massive charge and discharge currents in an extremely short time, the electronic control system must use high-end IGBTs, or silicon carbide SiC power modules. These power electronic components represent real, hard-earned hardware costs. No matter what specs of the car body you're making today, as long as high voltage, large current, and mechanical transmission are involved, the bottom line of the hardware BOM bill of materials is unbreakable. Part 2. The true cost of smart driving systems and automakers' calculations. Then you might ask, why don't I just cut out the LiDAR, computing chips, and all the autonomous driving software? Surely that saves some money, right? Let's do the math. A mainstream L2 plus level assisted driving hardware suite, a few millimeter wave radars, over a dozen cameras, plus an in-vehicle chip. The total hardware cost is actually around $30,000 to $50,000 NT. If you even downgrade the huge infotainment screen to traditional radio buttons, the limit might be lowering it by around $60,000 to $70,000 NT for an electric vehicle that easily costs over $1 million. This reduction of a mere tens of thousands is fundamentally insufficient to turn it from an expensive tech toy into a cheap commuter car for ordinary people. Moreover, from a system development perspective, the nature of software is extremely high R&D cost, but near zero replication cost. If an automaker spends $10 billion developing autonomous driving algorithms and only sells to 10,000 owners, then each car has to share $1 million in software costs. But if by standardizing the hardware, they forcibly push it to 1 million cars, then the shared software cost per car drops to just 10,000. The crueler reality is, automakers nowadays don't want to make money selling hardware at all. In the era of traditional ICE vehicles, the automaker sold you the car, and subsequent maintenance, oil changes, and transmission repairs were the steady stream of profit. But EVs have extremely few maintenance items, and the probability of motor and battery failure is low. If they only sell a dumb EV that's pure hardware, the moment it's sold, they can never make your money again. So they must turn the car into a large mobile server using OTA updates, subscription-based smart driving packages, and connected car data streams for continuous monetization. It's like many industrial equipments today. The hardware itself only charges a very low margin, relying on subsequent subscriptions, cloud monitoring services via Modbus communication, and data reports to earn profits. Part 3. The current state of the price gap between EVs and ICE vehicles in the Taiwan market. Let's bring our perspective back to the Taiwan market. If you want to buy a pure commuter ICE vehicle in Taiwan right now, like an entry-level Yaris Cross or MGZ's compact crossover, the price falls roughly just over 700,000 NT dollars. This price range is a sweet spot for car buying for many ordinary families. But if we look at the EV market in Taiwan, even the domestically produced high-cost performance Luxgen N7 or the hot hatch spec MG4, their starting prices are basically around 1 million to 1.1 million NT dollars. That is to say, in Taiwan, between an entry-level EV and an ICE vehicle of the same class, there exists a price gap of nearly 300,000 to 400,000 NT dollars. This absolute price gap of 300,000 is the biggest culprit stifling the buying momentum for cheap pure EVs. Today, if a consumer just wants a car to shelter from the wind and rain, commuting 20 kilometers a day for work, they don't care at all about 0-100 km/h acceleration in 3 seconds. Nor do they care about automatic highway lane changing. They do the math. The 300,000 saved by buying an ICE car is enough to pay for over a decade of gasoline, and conveniently pays off the annual license tax and basic maintenance fees in the face of such a massive hardware price gap. Any touting of EVs' environmental friendliness, quietness, and tech-savvy feel appears incredibly feeble. Why can't EV prices in Taiwan come down? Because Taiwan's auto market scale isn't large enough, unable to generate sufficient economies of scale to amortize the setup costs of battery factories and the three electric supply chain, lacking the support of a large localized supply chain. As long as this 300,000 barrier remains, electric vehicles in Taiwan can only be for early tech adopters or middle-class families, second cars, making it very difficult to truly become universally accessible to the masses. Part 4. Mainland China's cruel laboratory where electricity is cheaper than oil. But if we just turn our gaze to the Chinese auto market across the strait, you will know that if prices are identical, the hypothesis that EVs will definitely sell like crazy is absolutely 100% correct. The Chinese market has been staging an extremely bloody elimination round these past few years. They call it electricity and oil at the same price. And in the past 2 years, they've even directly shouted the slogan, "Electricity is cheaper than oil." Take BYD for example. Their Kin Plus and other models directly slashed the starting price to 798,10,000 RMB, which converts to just over 350,000 NT dollars. What does this mean? It means that in China, buying a new energy vehicle equipped with a large battery and high-efficiency motor is significantly cheaper than buying an ICE vehicle of the same class, such as the Nissan Sylphy or Toyota Corolla. When this death cross of electricity cheaper than oil appears, the entire market's tectonic plates instantly collapse. Consumers don't need to listen to any talk about carbon neutrality or green environmental propaganda, nor do they need to care if the car has top-tier autonomous driving. For those who run sales daily, or office workers commuting dozens of kilometers a day, the car is cheaper and the electricity cost per kilometer is only a tenth of the gas money, and maintenance doesn't even require oil changes. In the face of absolute cost performance, the sales of entry-level ICE vehicles from many traditional joint venture brands have directly crashed. They can achieve this not by doing charity, but through incredibly terrifying vertical integration capabilities and economies of scale. From upstream lithium mining and battery cell manufacturing, to the packaging of power electronics modules, doing everything entirely in-house. When battery costs are squeezed to the extreme, the total hardware manufacturing cost of EVs can officially fall below the traditional mechanical structure of an internal combustion engine plus a complex transmission. Conclusion. So, returning to our opening question, why is no automaker willing to make a pure EV that lacks smart driving but is extremely cheap?